I'm going to show them the link, and then I'm going to go ahead and get started again. But just show them the link real quick. All right, here's the link to the site. It's I googled that search term, and then it's this result right here. And if you scroll down to the bottom of the page, this is the sign up for the constant contact at the bottom. We're going to pick back up with the more complicated of the two authentication bypass. The first one, the SQL injection bypass, is it's not easy, but it's relatively easy compared to this next one, because the next one takes a little more digging and picking away at the application. The reason is that SQL, by its very nature, is fairly standardized even across different databases. So there's a tendency for the applications, if there is an authentication bypass opportunity, it's going to be more or less kind of the same way in different sites, even different languages. But when it comes to trying to mess with authorization controls, they're almost always custom to the application. And so you have to research every single app independently to try to figure out how it does authorization, and then figure out a way to do something that was unintended by the developer in order to gain extra privileges. So we're going to start by just trying to figure out how the site works. So if we go to, well, we're already on the home page. If we go to login and register, and then before we register or log in or anything, let's take a look at the cookies that we have so far. So we have one from Google, but nothing from this site at all. Let's refresh just to make sure. And I'm using Cookie Manager Plus in this particular browser. It's an add-on for Firefox, and there are a bunch of other add-ons that'll let you look at cookies as well. So there's no cookies that we can see right now. We'll go ahead and register for an account. Okay, so looks like we have an account. Go back to the login page. Let's see if we have any cookies yet. Not seeing anything yet. Let's try to log in. Well, at this point, there actually should be some cookies, so there might be something wrong with my Cookie Manager Plus. All right, well, we'll fall back on Burp Suite. So let's refresh the page and look at the parameters. So we have 4 cookies. We have the show hints cookie is currently set to 0. We have a username, which is the username that we registered for. That's important to note. Then there's something called a UID, maybe user ID, something like that. It's 17. And then we have a PHP session ID. So we know how our account looks right now as far as the cookies go. Okay, as far as trying to figure out how this site uses those cookies, what might be an easy way that we can try to figure this out? It's not necessarily a right answer, so.
I didn't hear the question.
What's that?
I didn't hear the question.
Okay, so we're trying to figure out what these cookies mean, what they do, try to figure out if there's some way that they give us our authorization levels. Because it's not uncommon for sites to make this mistake. Sometimes developers equate hidden or obscure from can't be changed. And so they think if you put something in a cookie, how could anybody possibly change that, right? But anything that's in a browser, it doesn't matter where it's stored in the browser, can be manipulated by the users. So you never want to store authentication tokens under any circumstances on the browser itself. And this is another one of those ones that got fixed, and we did really well as an industry for a couple of years, and now it's back on the uptick. So
kind of session stealing?
Session stealing would work against someone else. Probably one, again, there's not necessarily a right answer, but one technique that's good to put on your checklist is register for 2 accounts and compare those accounts to one another. Or if your customer is willing to give you an administrative account, and they also will give you a user account as well, of course, then you can compare the cookies for the user account against the cookies for the administrator account and try to see if there's any difference. Okay, so let's try to register again. We'll log out. There's certainly other techniques, but this is usually it's a pretty good place to start. I'm just going to refresh this registration page because I just want to see what the cookies say right now. So right now, when we're logged out, we don't have that UID or that username cookie. That kind of makes sense that we don't have the username cookie, right? Because we're not logged in as a username. But it's important to note that we don't have the UID. We're starting to see that that has something to do with authorization. So, by the way, a little side note, there's a vulnerability I've added in that if you go to security level 5, you know those hint bars that you can show? That when you go to security level 5, those bars will disappear on you and you won't have them anymore. There's a way to get them back, even in security level 5. And that actually is a feature. So I guess earlier I should have said there's at least one vulnerability that I do know of that's in security level 5, and it's in there on purpose. And it's closely related to this module. Registering for the second user. Oops, I gotta forward the request or we're gonna be here all day.
Oh, that's why my web page was just spinning.
Okay, now let's go check out cookies. We'll go to the login page, I guess, or home page, it doesn't matter. Okay, so nothing so far, looking good. And let's log in. And this time we'll look at it a little bit differently. We'll look for see if there's any set cookies. Okay. During the login process, we've trapped the response that's come back from the server. We can see that the username and the UID are set in the response that actually comes back from the server during the login process. So now we've essentially confirmed that they have something to do with either authentication or authorization or both. It'd be kind of weird that they come back during the login process if that wasn't the case.
Is that in the request or the response?
Set cookie is always in the response.
Okay.
Cookie is always in the request, because your browser is sending the cookie to the server to identify who it is. Otherwise, the server wouldn't know who you are because it's stateless protocol. HTTP doesn't remember between two different requests. The set cookie is always going to be coming back in the response from the server because it's the server telling your browser to set the cookie. That's a good question. All right, so we're just going to refresh this page. And now the user ID is 18, and the username is, of course, our username. So what was the UID of the first user, Canary? 17. And the second user is 18. So see a pattern here, right? Makes it easier when there's a really, really simple pattern like that. All right, so knowing that the UID seems to be the key to everything because it doesn't really appear that the username matters. I mean, it's just whatever username that we logged in with, so we already know in advance what it's going to be. We probably should focus on the UID field and manipulating that. Now, if 17 was the last user and 18 is the current, the registration we just did a second ago, what do you think the administrative user probably is? 1, 0, both good answers. Maybe -1, because trying to be tricky, right? So I've seen that before.
What, is there a way to randomize that data so that, or hash it so when you get to come back a non-sequential number, could it still be a key field that the database could pick up? Or?
There's all kinds of ways to try to get cute with it, but the best thing to do is just don't store it in the cookies.
Okay.
There's no reason to do that.
Okay.
There's no reason to put security tokens into the browser
Okay. Yeah.
at all. It
should be completely different tokenized.
even if you think that you've got this foolproof way, it's still kind of a double dog dare, right? Because you're sticking the authorization tokens into the hands of possibly malicious users. If you keep those tokens on the server side and keep them private, keep them in the server itself, there's less chance of manipulation. And certainly it's hard to understand how they work if you can't see them. So the correct way to fix that would be in the language. All the languages support this idea of a session scope where you can store variables in this container that's tied to the session. And you would put those authorization tokens in that container. Cold Fusion supports it, Java, PHP all support session storage. The nice thing about using that container to put those variables in is that when the session disappears, the entire container goes with it. So that would be the best practice. And certainly if you have any questions about remediation, I'd be happy to answer those as well. Actually, usually that's what I teach is remediation. Typically don't get to do this fun stuff very often, but so this is nice. Okay, so let's try to change that to 0 and just see what happens. Well, that didn't work out so well. Let's try 1. Oh, well that worked out better. So I'm not sure if you can see that. So now instead of being logged in as us, the Canary 2 user was the one we actually authenticated as. We've escalated privileges to administrator by manipulating the token that represents the authorization level in the site. All right, so that is cookie manipulation for, really that was probably more authorization bypass that we just demoed. That really wasn't authentication bypass because we were authenticated. We just went from user to administrator. We could turn it into an authorization bypass, and the way we would do that is to emulate those set cookie statements, or just use something like Cookie Manager to add the cookie in. So you would click add, and then give it a name and so forth. So I think add and edit cookies works pretty well. There's a couple of others that are pretty good as well, where you can just create the cookies on the fly or alter them or edit them in a little text browser. So is there any questions on administrative bypass, either from the SQL injection or the cookie manipulation? All right, we're going to take a look at local file inclusion now. So I know some folks were trying to get updates of Matilda to get the latest version, and I did have one question about like what's in the 2.5 family and what's the differences between the versions and so forth. So in 2.5, this new hint system, the one that has the little bar that appears with the dynamic elements in it. So if we go to like go to like a different page, HTML5 storage target. So this bar here, this is introduced in 2.5. There used to be just hints that were hard-coded at the bottom of each page. Didn't work out too well because you either had to copy the hints from page to page, or I'd forget a page every once in a while and leave the hint off. Plus it wasn't modular, they weren't broken out. But in the new system, this hint is separate from this hint. They can be looked at independently. And the new hint system has things broken out into better divisions. So that's the main difference. So if you want to update, or if you want to know when updates come out, it's kind of already here on the left. But I set up this Twitter account here to tweet when new videos come out on the YouTube channel and when new versions of Matilda come out on SourceForge. And the Matilda channel has about 80 or so videos that were recorded, kind of like this, kind of like today. Some of them are very short, some of them are over an hour, it just kind of varies. But they basically talk about different topics like this, some of which we're covering today, a lot of which we're not necessarily going to cover today. About 50 of them are on web and about 30 of them are on network pen testing. So if you want to know when the new videos come out or when the new Matilda comes out, just you can subscribe to the Twitter. All right, so I'm going to do the local file inclusion. I think we're going to use the source code viewer page. Well, actually, let's just use the home page. Okay, let's take a look at what variables we have on this page that we could possibly fuzz. Okay, so we've got 4 cookies, and we have a URL page parameter. So basically have 5 injection points. So out of the 5, as far as file inclusion goes, what seems to be the best bet? Yep, that's the value. So see, the value itself is actually a file name. So that's a real good clue right off the bat that you would want to try some local or remote file inclusion, or including URIs or something like that. If the value appears to be a path or a file name or both possibly, then that would be a good target. So let's try to cause an error and see what happens. We'll just put like home2.php. Okay, these are some pretty useful errors. We have a require once. So apparently the way the PHP source code is working is there's a require once statement that fetches the file at runtime and loads it into this frame here. And whenever we include the name of a file like home2.php that doesn't exist, the error message helps us out. So this is obviously an application exception vulnerability that we've created here. And what other vulnerabilities do we have subtypes, I should say, inside of this application error message.
What have we done with the error?
So, yeah, what,
Is that right? I'm on 257.
yep, so we have a platform path in here somewhere. Here's one. But here's the really good one. Here's the really good one. So let's copy that one down. And then we have another platform path disclosure here. It's also an application path as well, in addition to being a platform path. So this tells us that this page index.php is 1, 2, 3 levels deep in the file system. It also tells us another mistake is the web application is running in the same volume as the system root itself. So it's kind of subtle, but just this little bit of information tells us that there's another vulnerability. You know, the way that this system should have been designed is should have created a second volume and put the website over on a different volume altogether. Okay, so let's remember that. Now, one of the problems we're going to have is we only type in home.php. We didn't type in c:\/ blah, 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 home.php, right? But it still prepended all that stuff onto the front of it. It appended that platform path onto the front. So even if right here, even if we type in, boot.ini, it's not going to find that file because boot.ini is in the C drive root directory, and we're trying to fetch it in the czamp htdocs matilda index.php directory. So this isn't going to work too well. But one of the things we can do is hope that there's a directory traversal vulnerability in the system that would let us go up a few levels and then come back down the file system again. So we'll try the easiest way, which is the ... And this is a Windows system, so we use \. And we'll go up 3 levels, because we know how many levels there are. And we'll see if that works. So instead of getting an error, we've actually got some text from Windows. So you can see where this is going, right? It's going to get fun. So another thing that we can do is this is a web server, right? And web servers have source code. And source code is really good to read when you're trying to mess with the system, trying to do something that wasn't intended. So maybe one of the things we can do is try to see if there's some way to get at some of the include files or something like that. So some common include files would be something like config.inc. That one's really popular. Web.xml, web.config. What was that other one?
php.info.
php.info.
htaccess.
Yep, htaccess is an Apache file. So, but we need to figure out some ways to get some more information to give us some hints about where the source code might be. And does anybody think of some ways we can do that?
Command injection and start doing directories or ls.
Oh yeah, if we got command injection, you could definitely figure it out for sure. But something easier to do even than that, like what would every single site more or less pretty much have to tell the browsers or the web crawlers to go away and don't look at stuff. Yeah, don't.
Sorry.
Yeah, please don't demo
Maniacal laugh.
demo that today. So.
I'm not going to demo that today, no.
All right. So it's the index.php, and take that out and put robots.txt. Okay. So it doesn't want us to go into the passwords directory, and it doesn't want us to go into documentation and php myadmin. So those are pretty good targets. So let's try, oh, and there was includes too. Sorry, I went too fast, I skipped off of it, but there was that includes directory. So let's try includes config.inc. Okay, so it's a blank page. Should we just go on, or what could we try? Mentioned this very early on, very first thing this morning, mentioned something about the browser and when things come back in it. Yeah, view source. So Control U in Firefox. So you're going to get used to looking at the page this way, and don't look at what Firefox tells you. So every once in a while there'll be something in there. And I'm not seeing anything. All right, let's try the robots again, so we can get a better handle on it. Oh, hey, Adrian.
I don't know if they fixed this in some other web servers or not. I was wondering if you had any luck with this before. Now, some people have content engines where they automatically paste on an extension no matter what you put in to keep you from being able to do completely arbitrary includes.
Yes.
So I've seen people tack on a %00 to put a null character in there
Right.
to terminate the string. Have they done things to fix that? Because I've been having a problem getting it to actually work recently.
Yep, I want to say, if I'm not mistaken, ASP.NET at 3.5 has that fixed, maybe even earlier. Not sure about PHP. So what Adrian is talking about is, in addition to having prefixes added to the file path, there can be suffixes too, like maybe the developer always adds .aspx to the end of everything that's passed in, for example, because they're trying to make us a valid file name. And so he suggested sending in %0, which is a null character, because string functions in the operating system, when they hit the null character, will stop reading the input, and so it'll prevent them from reading the .aspx. And so whatever you type in will be the suffix or the file extension, and you won't get the extra stuff added on.
And you could usually see that in the error. If it prepends everything with .php, that's a good time to use %00.
Yeah, and PHP, I think does usually honor the %00 because I think it's written in C or something like that. So it's one of those languages that honors the null byte. Uses it as a string terminator. Okay. Well, being stubborn, I'm still trying to find that config.inc, but it's not coming up. So. All right, well, let's go after some other files. So one of the things I did is I went out and to Rob Fuller's site. I believe he goes by the handle of Mubix, if I'm not mistaken. And he has already done a lot of work in compiling lists of files that you should try if you somehow gain access to a system. And is speaking generically, so he's saying, you know, whether you gain access via an interpreter or via a web exploit or command injection or whatever, once you get in, however you do it, here's a nice list of files broken down by operating system that you should try to acquire. So to make this a little bit easier, I added these to the hints, but credit to him for putting the list together. So if we go to local file inclusion hint, which you can see on the source code viewer page, went a little quick there. Let's see, A3, no. There's so many vulnerabilities, it's getting hard to actually find them. And that's terrible considering I've built a site. But I can't remember anymore. Let's see, source code viewer, other injection. there it is, A4. Somebody said that. Thanks, I just went too fast. Source viewer, A4, source viewer. And there's local file inclusion hints. And there's a couple of other pages as well. Okay, so these are the files that he had for Windows, and then he has a whole bunch more for Linux. And I only grabbed just kind of a few of them that I thought were really good, but so we can try this one. And even if the WinDir thing doesn't resolve, that's okay, because we had that platform path disclosure that basically told us pretty much what the Windows directory is probably going to be anyway. So we'll do our directory traversal to break out of the prefix, and we'll see if this works. And we'll copy this. Probably could try encoding those percent signs and maybe we'd have better luck, but we pretty well already know what the path is because of that earlier problem. Okay, and there's the host file. And this is in the system32 directory, so if we can read one file in systems32, we can read a whole bunch more of them. There's going to be a few that you can't read. They're locked when the operating system is running, but you'll definitely be able to get at a bunch of them. And if you can read the system32 directory, you can probably pretty well just dump the entire disk. That's the directory that's hardest to get into on Windows. Okay, so that's the basics of local file inclusion, and what I'd like to do is have Adrian show you some examples of local file inclusion that he's been working on with injecting web shells that we talked about earlier with the SQL injection with the local file inclusion vulnerability. So to kind of put this in perspective, the web shell is your payload. That's not the vulnerability. The local file inclusion is the vulnerability. So we're going to use the vulnerability to have a second method of getting our payload to execute. Come on up. Why don't we take 5 minutes and give him time to set up. So we'll start again at 12:46 on this clock up here.